Welcome everyone to Ellenox's Industrial Voices podcast. Today we have with us our amazing guest Arvaind, founder CEO of Inbound Aerospace. Amazing news. They recently raised around $1 million in their pre-seed seed round, and I am super excited to have him here. They are at the forefront of Indian space race, and I'm gonna just leave it off to Arvaind. Arvaind, how are you doing today?
All good, all good. Thanks for having me here, Prashant.
That's great, Arvind. So, Arvind, how did you like? I know aerospace is a crazy space, right? Like, space is a crazy space. Like, we use the word, "Is this isn't rocket science" as a thing, right? So, you are literally doing rocket science right now, right? How did you end up there?
Yeah, so I have a background in aerospace propulsion. I did my PhD in liquid rocket engine, focusing on
Mm-hmm.
combustion instability. It's a problem that is actually occurred in liquid rockets. So this was actually at the aerospace department of IIT Madras, and while I was doing the PhD, I was also volunteering uh, in some of the activities uh, of the microgravity drop test tower that is there in the building that we were, or it was the lab in which I was doing my PhD. It is called as the National Center for Combustion
Yeah.
Research and Development. So it has a unique test facility. It is the only facility in the world. This is a tower in which a payload is dropped from a 30-meter height, and the payload experiences weightlessness for about 2 seconds. So this is the fourth largest in the world in terms of duration,
Okay.
and the only facility in India. So this is where actually it started, but because you only have 2 seconds, we were actually seeing a lot of challenges and many of these experiments were fluid dynamics and combustion experiments. So this actually, and it goes and hits in this payload that comes and falls from the top of the tower. It goes and through the 30-meter distance takes about 10 seconds to reach the bottom, and the final 2 seconds is what you get the weightlessness. And then right after that, it goes and hits in an airbag. So this actually created a challenge where we were not sure whether the experiments were actually steady, have reached the steady state or not. So because the 2 seconds was too low, so some of the uh, image processing or data processing was what actually I was mostly directly involved in of these experiments. So that actually we were not sure whether it was actually really microgravity is achieved, or the effects of gravity is completely nullified, or is it still there and the system is moving towards that state. So that is when I actually started looking at how can we actually get long duration zero gravity. So
Mm-hmm.
this researching in that direction of where do we actually get for longer duration led into a understanding that currently the only place where you can do long duration is the International Space Station.
Yes,
So,
ISS.
okay, so now I thought, okay, now International Space Station is the way to go. So now, how do you actually get to fly a payload there? So that is where when I actually came understood that there are a lot of challenges in getting access to International Space Station, and partly because of India is not a partner country in the International Space Station, and you have to go through a huge waiting period to get an access to that, to typically 2 to 4 years, and astronauts are involved, so your payload safety is actually the uh, highest priority. So a lot of additional
Yes.
qualification tests need to be performed in that. And
Mm-hmm.
then it problem didn't
Mm-hmm.
end here. Once you are getting a chance to do the experiment, you still have to wait for an extended period of time to come back because there are not many return vehicles coming back. So I think now this was actually
Yes.
not understood with Sunda Williams and Bush Milmore had to stay there for an extended duration because not many
Yes.
vehicles are coming back as often as launch vehicles are being launched. So return vehicles
Yes.
was actually a bottleneck, on-demand return vehicle. So many payloads cannot be
Yes.
brought back for the same reason. So you cannot wait your biological specimens or biological experimental material. For example, rat specimens or something cannot be brought back immediately. So they will have to be
Yes.
killed or something like that. So this was a challenge actually that was from the beginning.
Mm-hmm.
That is where actually we looked at, and while coming back also these are brought back in what is known as capsules. So Gaganyaan crew module is a capsule.
Yes.
SpaceX Dragon is a capsule. So these capsules, when it
Yes.
falls from the sky or falls from the space back to Earth and they land in the ocean, they actually undergo very high deceleration loops. While coming back, it's very high deceleration load up to 3 to 6 Gs. That is why the astronauts have to go
Yes.
through this post training. So many
Yes.
payloads will get crushed in this also. So for I think there was one comment where the 1 year worth of experiment got spoiled in the last half an hour because of dragon. It came
I was
back
gonna
in a
ask.
dragon. So biological specimen came back in a dragon. So this was the challenges that were
Mm-hmm.
identified in, and then International Space Station is also scheduled to be decommissioned by 2030. So this,
Mm-hmm.
what I felt there was, okay, now there is actually going to be a gap in platform to do zero gravity experiments. So that is when I actually decided now is actually the time to start solving this so that you are actually well established by the time the station is actually decommissioned and no commercial players come, or uh, you actually can transition the research from zero gravity research from International Space Station to, or customers can do transition the research from doing it on the zero gravity International Space Station to the unmanned free flying payload vehicles like us. So what this
Yes.
vehicle is actually go the satellite. Uh, yeah. So this doesn't
Mm-hmm.
go looks like a normal. Sorry. Yeah.
No, no. I mean, continue. I mean, we've gotten very deep into the technical side. We'll get there very quickly,
Okay.
right? Next step is that my you basically answered most of my questions up front.
Yeah.
But before we get all the way into what inbound itself does, right?
Yeah.
Or what your
Hmm.
actual technology is, let's take a step back, right? Like let's take a lot of steps back. Uh, I know you did your PhD at IIT Madras,
Correct.
and right there you were seeing this issue with microgravity experiments or zero gravity experiments failing, mainly around the problem that we don't have enough understanding of the physics in the last 2 seconds, or like whether that can be extrapolated towards your actual final experiment is what I'm guessing. Correct me if
Yeah,
I'm wrong.
enough duration was actually not enough actually. So the duration
Yeah,
of the
duration and
yeah
also
duration
got
yeah and
got
the
it. And
duration of the
then the
experiments were
other
always a
alternative
challenge.
is yes, yes. And the other alternative is go all the way into ISS, which
Correct.
not everyone has access to. It's very expensive, and also it's a big challenge. Like recently we saw there was an issue in the docking module, if I'm not wrong,
Hmm.
and the members had to stay for longer than anticipated in ISS,
Hmm.
correct?
Correct.
And that was an example of problems that can happen. And if your experiment was supposed to be back pretty early on, then you can't extend the time period, and everything is a little bit more challenging, and it's
Correct.
a lot more expensive. Now,
Hmm.
I do know that that is one side that gave you the overall idea of building this, but now let's take a step back into Indian context and your context, right? I know before 2020, if I'm not wrong, space industry was heavily regulated in India,
Correct.
correct? And I think something in 2020 changed, and we have a boom of space industries. We have a lot of them. There's like a lot of startups. There's a lot of money pumped into Indian space technology companies. So can you tell me what happened there? What was the difference?
Yeah. So after the around the time 2020, government actually brought in reforms in the Indian space industry where private players can actually enter into launch vehicle and or space activities in an extended manner. Until that time, it was only through ISRO you would be able to do this. But after the reforms,
Yes.
you were able to do this. You were able to launch rockets from Indian soil. You were able to retrieve re-entry vehicles are also there. Satellites were also there, and also ISRO test facilities were
Got it.
also open to the private players. You could actually
Mm-hmm.
use the test facilities of ISRO and then pay for it according to the charges. And this was actually completely new. So this was actually at the same time while I was doing research, I was also going through of Indian reforms and going understanding and meeting, going to a lot of conferences also in India of what is happening in India. So this led to also awareness, understanding that now is the best time to do a space startup in India. because actually the government support is huge. Actually, we have seen directly. So
Yes,
ISRO is
yes, indeed.
government has
Indeed.
mandated that private players be startup be supported, and it also led to
Yeah.
the creation of an entity known as InSpace, Indian National Space Promotion
Mm-hmm.
and Authorization Entity or Authorization Center.
Okay.
So this actually is actually able to support, nurture, and also promote and regulate the space activities in India. So now there is a structured form in India where how do you can actually get a launch? How do you get a to permission to get to a launch? So all
Makes
how do
sense.
you get access to a ISRO facility? So all this actually started falling into place with the Indian government pitching in. So that actually led to uh, investors actually in more confidence in the Indian market. So that is where actually a lot of
Yes,
large
yes.
fundraise happened. Some of the launch vehicle players earlier had
Yeah,
raised huge funds in early stage, which was not
makes
possible
sense.
before the reforms were reforms were made.
Absolutely. Makes sense. Makes sense. I think the huge government support, and I'm also guessing a lot of ISRO, IITs pushing heavily through their research labs has helped a lot. Now,
Correct.
that's a great thing to hear, right? Like hearing that we are making strides thanks to support from the government, but not instead of the government. Most of the times, it's like, oh, instead of the government doing this, we are able to do this. Right
Hmm.
now, it's actually because of the government initiative, we are able to get forward, move forward for the private players and for the industry. And I think that's great. Now, let's take the next step in this conversation, right? Like, I know you've spoken about how you got this idea, mainly
Hmm.
from your lab experience at IIT Madras, right? So, how did you build your team out? Like, what was your team like?
So initially it was just me alone. Then we were so because I was a student at IIT Madras, there is this
Mm-hmm.
concept known as pre-incubation, which is
Mm-hmm.
inside the campus. It's called as Nirman. So it's a pre-incubator of
Mm-hmm.
IIT. So there, the concept is the idea is you can actually submit your startup idea. You don't have to register your
Mm-hmm.
company actually, but they give you funding support. They give you a place to workspace. They give you actually place to build your early some of the prototypes, and you can also build
Yeah.
your team from there. Actually. So this place was actually used as a starting point where we could actually get directly access to the team students. So many of the
Got it. Got
interns
it.
actually I started going through this, and then I also reached out to some of my uh, so Vishal and Abhijit were my co-founders. So Vishal actually I knew from a long back, actually more than 10 years now. So I
Okay.
reached out to him. He had a background in BTech in mechanical from VIT, and then he went to do his masters in Columbia University in engineering management, and then he was with Tesla. And then
Mm-hmm.
I thought he was still in Tesla, and then I reached out to him that can you come back and we can join this together. So fortunately, he actually took the decision to come back because his plans was after the Tesla, he wanted to move into SpaceX. So that space plan did
Got
not
it.
happen. So he just came back to India. He
Got
took
it.
the decision to
Got
come
it.
back.
Got it.
So at the same time, this was
Uh,
in early 2024. So at that time, he directly joined, and then he were together. At the same time is when Captain Abhijit, joined. So his story is like he was a MiG-29 fighter pilot in the Indian Navy, and he
got
was
it.
also cleared the test pilot uh, exams, and he was training with the training for his test pilot. And at that time is when Indian Navy India decided to procure the INS Vikramaditya aircraft carrier. So he was
Yes.
sent into Russia for this procurement, and then his test
Mm-hmm.
pilot training could not be completed. So
Got it.
what happened was that after around somewhere around 2017, 2018, when ISRO wanted to actually select astronauts, uh,
Mm-hmm.
the test pilot clearing the test pilots was actually a requirement. So that actually did not
Got it.
because he couldn't complete it. He was not able to uh, was not selected. Only the Air Force
Ah.
two. He was actually training with the two astronauts, Ajit Krishna and Prashant Balachandra. He was training with them, and
Mm-hmm.
but what happened because of this deviation to inductions? squadron of the INS Vikramaditya. This actually direction did not happen. So after coming back, actually, I think he rose to a position where you will not have much more flying left. So he took a conscious decision to move away from Navy, and he wanted to get into the space tourism area, which is a human spaceflight portion of it. That is when he started attending because he wanted to become an astronaut also. So he started attending conferences, and that is when I met me, and then we were talking, bouncing off ideas for around 6 months, and at the same time when Vishal joined January 2024, he also joined. At that time, it was still not registered. It was still an idea that we were just working on it with the interns at IIT Madras in the pre-incubator. And then from there, actually, we slowly reached out and then started building more and more teams. So now, right now, we have a team of 25 people, actually. Yeah.
That is great. Like I know, starting from you individually, then picking up your founding members, and then getting all the way to a 25-member team. And the critical piece here I hear is the immense support you got from IIT Madras, not just from your PhD time, but also the pre-incubation, that was Nirman, and then also your ability to raise initial funds and also get your team together. And that must have been super helpful. I'm sure you now are located in IIT Madras, Madras itself, right? Like they have
Correct.
a startup
Yeah.
accelerator program, or is it sort of
No.
what is it?
So initially it was in the pre-incubator, so where we had this workspace access to funding support will be there, and also access to investors, because many of the alumni are investors and who they come to campus, and you get a platform to become more visible. That is what's there. Then the natural progression from there was the incubation, getting into formally incubated. So that is when you actually incorporate your company and then get incubated. That is in the IIT Madras research part. So we were there, and then we moved out from incubation cell, taken up our own space in the research part. So that is where currently we are, actually.
And that's the natural progress, right? You first get pre-incubated, incubated, and then you actually get all space with them. That is pretty cool. That's like immense support, and I'm sure with all the talent there, with all the funding access, it opens up a lot of opportunities. That's great to hear. Now, now let's move into more of your, challenges. I know you were raising capital. What kind of challenges did you face? I know how long was your overall fundraise time?
Yeah. So it was difficult to raise the first round because of the fact that first we would have to make them understand what microgravity is or zero gravity is, and why do we have to go to space to do this? So people, the most common question that I was getting is, why do you have to go to space to do to turn off gravity or to do this, to make new products in space? Why can't actually be recreated or simulated in Earth? So the fact is, we cannot simulate in Earth for longer duration. That was the actually starting point of the whole idea itself. But that actually took a lot of time. And then it was a newer market in India, because in-space manufacturing or the in-space manufacturing means products that can be made only in this zero gravity environment due to the advantages of that, but have applications back on Earth. So that cannot be created on Earth, but those products have application back on Earth. So this is the area in which we are looking at. So this
Got it.
market is a very, very early market, actually. So because, as I said, International Space Station is a research station. So you actually are able to only do research. So now that research is actually entering into a commercial phase. Many of these products that was researched in the International Space Station now are entering into commercial space. So it's like the internet in 1990s. So it was an early market for this in-space manufacturing. So that actually led to a lot of difficulty in convincing the investors. But it took time. We took actually around 6 months actually to finally close it and close the round. But initially, it was partly because of building the team, incorporation, all this process were simultaneously also happening. And the incubation, and then some traction was also actually happening in it. So this is where actually it took around 6 to 7 months to finally close the round. Partly because of the fact that it was a newer area, which many people found it difficult to appreciate, because it was not there in India, actually.
Yes. I mean, we understand the challenge, right? Like most times for investors, especially in India. I mean, I'm not going to call about the sophisticated investors, but if you're going to a lot of family offices, they don't understand deep tech. They don't understand technology in general. They understand what we call dhanda, right? They understand money making opportunities. They see that there is money here. All you need to do is put in more money, and that will turn into something bigger. But when it
Yes,
comes to technology and deeper tech, it's harder for them to get the full grasp, right? Now let's now move on to the next step, right? Like you've gotten your funding, you got in your team. Now, next comes the product, right? So now the biggest question for me is, how did you end up deciding that your current version of the answer is the answer? Because there's also, like, obviously there is ISS, then there's these microgravity research towers, but then there's also parabolic flights, then there's
correct.
also like very high, if I'm not wrong, there are some things that are related to research balloons that are dropped from very heights, you know there are like few of these also, if I'm not wrong, correct me
Correct.
if I'm wrong.
Yeah.
Uh, so how did you pick your current solution, which I'm guessing is a suborbital rocket, right? Like what you're building is a suborbital rocket or something along those lines.
Okay.
Correct me if I'm wrong. This is my
Yeah. Yeah.
understanding based on your website
Yeah.
and general stuff, right?
Yeah.
So, how did you end up picking the current version?
So as I said earlier, so when I started looking at this problem associated with
Mm-hmm.
International Space Station, then the direction is how do I actually address these problems of getting
Mm-hmm.
waiting time, long duration of waiting time, human safety
Mm-hmm.
considerations, and unavailability of on-demand return vehicle, high G loads during coming back. So all this actually led
Returns.
to so the understanding of how do we get longer duration of gravity led to a chart where or led to a conclusion that you can actually get in multiple platforms are there. One is the drop tower, which is up to 10 seconds,
Yes.
and India has
Mm-hmm.
the 2 second one, which is the fourth largest. Then there is parabolic
Mm-hmm.
flights, as you mentioned. There you get up to 20
Yes.
seconds of zero gravity time. Then
Yes.
you get next one is the sounding rocket or suborbital rocket, like the way Blue Origin space
Mm-hmm.
tourism is
Yes.
performed. So there you get up to 3 to 4 minutes,
Yes.
and then the longer duration is only
Mm-hmm.
the International Space Station. So this area,
Yes.
what we were actually I was looking at is a newer segment known as unmanned free flying spacecraft. Unmanned free flying means it's an there's no human in the
Got
loop.
it.
It is launched into orbit
Yes.
around the free flying means it is not going and attaching into a station. It is just orbiting around the Earth like a normal satellite. Anything, all satellites that are launched into orbit experiences weightlessness. It is just that this satellite has the volume to do some this thing, and then it is able to come back. That is the only thing.
Got it.
So now in this one I was unmanned free flying payloads are also able to provide longer duration of experiment. And why we need longer duration? Many of these payloads, for example, we tried in the IIT Madras. This one there was also a discussion about doing growing diamonds, lab grown diamonds in this condition. So very high purity diamonds could be made in this environment, uh, which cannot be created on Earth. And semiconductor crystals with very high purity also can be made. And some of the industrial optics, protein crystals, um,
Mm-hmm.
optical fibers are also in the crystallization, and also 3D bioprinting. So all this requires more than few minutes of zero gravity time. So many products are also
Got it.
limited by the time duration. So that is why the reason International Space Station exists. There you get a continuous zero gravity time. So this
Yeah.
was actually the reason. But if you can remove the human out of the loop, lot of uh, additional qualification because astronaut science are very expensive. So that actually can
Yes.
bring down the cost of actually doing the entire experiment or entire process and coming back. And you can
Got
return
it.
on demand also. So this was the conclusion after I went into doing a research on this, and then looked at okay now how do you address the problem of coming back with the high G loads? So that is when actually the lifting body kind of a form factor actually helped us. So Space Shuttle was able to bring back payloads with a maximum G load
Yes.
of 2 Gs. But once the Space Shuttle was
Two Gs.
actually decommissioned, it was that capability was lost. So
Got
so
it.
this decision is actually, and I wanted to actually make it in a smaller form factor because you can go in a small launch vehicle. So small launch vehicles are solving the problem of on-demand launch. And if you can actually fit in the spacecraft or this space shuttle kind of thing that you can call, inside the small launch vehicle, you can complete the loop. So where it is
Makes sense.
a small on-demand launch and on-demand return. So this enabled made me to. It's a trade-off study of not having the capsule, but not having the winged vehicle like the space shuttle. So it's an in-between shape. It is not a lifting body shape. There are no wings to the spacecraft, but it is able to glide. It's able to fly, or it's able to glide back like an unpowered glider.
Makes
So that
sense.
is where the concept came actually. So this idea was looked at actually.
Got
Yeah.
it.
So
So
this.
basically, we put a space shuttle in the orbit, run your experiments for, I don't know, maybe days is what I'm guessing, or like
Yeah,
hours.
so
What
we
is
could
the expected
this
behavior? And
could stay
then
up to 2 months. This could stay up to 2 months, which are so
got it.
typical
That is
experiment
great.
duration, which most of the majority of the experiments requires are actually few weeks. 1 to 2 weeks is actually their want actually. So 2 months is a very very good time period where a lot of things can be made. A large majority of the experiments
Got
can
it.
be classified in come inside that.
And and then post that you just deorbit as if it's just passing through, like it just descends slowly onto the earth, and instead
Correct.
of just dropping straight, like that's what a lot of space shuttles and all the return
Absolutely.
vehicles do. They just drop straight. What you're doing is you get the gliding mechanism to slowly deorbit it and get back things into the earth's atmosphere and then land it on a runway.
Correct.
Correct me if
So
I'm wrong.
correct. Yeah. So this
That
is
is
so the
amazing.
mission.
That's rocket science
Yeah,
right there.
it's a challenging problem. So the mission profile is like it's launched in a rocket. It's injected into or put into orbit around the Earth, around low Earth orbit, three,
Yes.
400, and then actually it is able to stay in orbit for up to 2 months. So anything that is put into a 400 kilometer about there naturally takes around 45 to 60 days to decay. So that time you are getting for
Yes,
like
exactly.
immediately you're getting that time for no other additional energy input. So
Yeah.
you can actually stay in orbit and you take around that
Yes.
many days to orbit. So 1 month mission is actually very, very feasible in that. And then once the experiment is completed and the next available opportunity or re-entry opportunity by means you are flying over the target location or near the target location, your path will be flying over the target location. And then during that time, you can actually do the deorbit maneuver and then start to coast towards the Earth atmosphere. And once you hit the atmosphere around 120 kilometer, then it's a gliding unpowered glider where it starts to manage its energy
Yeah.
and then reach the location. And you get only one chance. Yes, it is only there is no going back and coming back and landing. It's just one
Obviously.
time, and that is the
That
challenge
that's
involved.
that's always the
Yeah.
case. I mean, that's the control systems, right? Like,
Correct.
that's the control systems that you have to design properly, right?
Correct.
So what I am guessing, so I know how challenging it is because I have a background in mechanical engineering, nonlinear control, and control systems. So I understand how hard of a problem that is. I don't know how people understand how hard of a problem that is, but that's insanely hard given all the variables that you have to take into account.
Hmm.
So my question is, where are we right now with respect to this? Are you all at the science level? Are you all still on pen and paper, got the equations down? You'll have simulated the overall thing, and now is that part done? Have you all had that? Is that rock solid and you'll have run hundreds of simulations? Or where are you all right now? Are you all in manufacturing stage? What's the situation?
Okay, so currently multiple subsystems are in various stages of R&D. So this entire spacecraft has a lot of subsystems in different disciplines, and
Yes.
could
Yes.
actually be the re-entry guidance one, and the shape itself is actually need to be evolved such that it is able to survive it is should be able to glide. It should be able to survive the heating condition. It should be able to survive the loads. The maximum G load is actually we are targeting of 1.5 Gs, and it should also be able to be controllable. That means from a stability point of view, a lot of control should be able to dissipate its energy in a controlled manner. And then there are a lot of mechanisms in this. So all this are actually in various stages. Some of them are actually in the testing. Some of them are in the simulation. In fact, the shape is already arrived at, and then we are actually getting into fabrication of the shape to do some of the earlier analysis.
Got it.
And then some of the mechanisms are actually being tested. In fact, propulsion system is actually test fired. we actually testified a smaller propulsion. These are green propulsion systems. So because you wanted to make your experiments or the vehicle hazard free as possible. So there are no explosive based mechanisms. It's completely non-pyro based mechanisms. It
Got
is
it.
uh, it is able to the re-entry is actually itself is divided into different uh, phases. So there is a re-entry high heating phase, then there is an energy management phase, and then there is a final approach and landing phase. All these are separately done. Multiple of these are
Yeah.
simulation done, and finally the approach and landing phase, some tests are actually planned in June. So that is where actually the aerodynamic shape is actually getting fabricated. So that is the current shape, current status,
Got it.
and some of them are gearing up for test actually. In fact, one test was done for the propulsion. One more test is actually happening next week, as we say, because it's already getting installed and getting ready. So some of the earlier cold flow test is already done. And so this propulsion system is actually smaller thrusters used to change the orientation while in orbit. That is
Yes.
actually being
Yes.
used to.
Yes.
So up to 80 kilometers, you will also have to use the thrusters to change your orientation, not only the flaps. Then and then the
Mhm.
other mechanisms like landing mechanisms, or it could be flap control mechanisms that is used to change the vehicles. So these are aerodynamic control surfaces. So they actually have a mechanisms,
Yeah.
and these are electromechanical based. So those are also being simulated. So they're in the simulation phase, and then there is a initial some progress is made in that into terms of some hardware. Early hardware is actually also being developed in that, and yeah. So and mission studies are also being progressing, and we are also talking to multiple launch players currently of getting, and depending on that, what is the first mission and how long. So the first mission is to actually to prove the re-entry, which is the heart of the problem, if you can say. That is the most challenging aspect. So the re-entry from 120 to zero is actually zero kilometer height is actually what we want to show. So we would want to actually achieve precision landing and control re-entry, and also go through able to prove the gliding capability of the vehicle or the aerodynamic capability of the vehicle. So the aerothermal, structural and control aspects will be proven in the first phase. There may not be payload in the
Got it.
first mission, but the main challenge is this one. So that
Yeah.
will be first time in the country. So someone will be landing precisely at a land location, and that is actually all progress that's going on this actually. Yeah.
Makes sense. I think those are like a lot of challenges, right? And getting all of them together and building a one single system is very, very, very hard and challenging. And I know this. Uh, Build smaller systems, work at places that build larger systems, and we saw how expensive hardware gets, how expensive hardware experimentation is, right?
Yes. Yes.
You can simulate everything with pen and paper, but once you put it into real world, there will be these edge cases that will just destroy you, and you have to go back to scratch and do stuff. So
Correct.
I understand that. Given that there are so many constraints, like, are you looking to raise a lot more? Because this is
Yeah.
something that would need a lot of money. I'll be honest, right? Like,
Correct.
you're
Yeah. So
literally
this
putting things
first
in space
fundraise.
and then getting things out.
Yeah, so the first fundraiser was only to actually get into a early review, preliminary recent review of that, and actually get into an early test that will be happening in June. Some milestones, the launch itself will be actually need to be looked at the next fundraise. Actually. So that is we will kickstart that with the after June test. So that is we are all getting towards that actually. That is the current. Definitely, as you mentioned, yeah, a lot more fund definitely will be needed to actually sponsor fund the launch itself. So that will be the next phase. Actually.
Makes sense.
Mm.
Got it, got it. I guess I mean I'm super like excited to see this launch. I would love to see it, get a video or whatever. I'm super excited for that, right?
Yeah.
Now let's get back into the technical, a little bit more into the operational, the actual money making side for your business. That is
Mm.
microgravity research, right?
Correct.
That's where majority of your overall final product is. So now I'm trying to understand, are you all becoming a platform for microgravity research like AWS for cloud? Are you all trying to become that where you do a lot of pre-structuring? Because again, micro not everyone understands microgravity research. Not everyone understands your systems as you all do.
Yeah.
Not everyone understands the limitations and stuff. So how are you structuring this for customers? Like, I'm sure there will be customers who would be like, we want to do this. This is our test bed, right? Are you all building test beds for them to, set up stuff initially and then push it out?
Yeah.
When does that come into your overall build pipeline, like
Yeah.
development pipeline? Right now, you all are in the what we call as building the platform layer, but
Correct.
then there is still the core of the platform, not just the re-entry and everything, because there's one more very important piece. That
Yeah.
is the actual microgravity experimentation and the what you call the harness for experimentation itself, right?
Correct.
What kind of sizes are people to expect in
Yeah.
comparison to
So
what are out
correct.
there?
Yeah. So the way we look is we look at ourselves as a space logistics player rather than
Mm-hmm.
so. So the way we work with middlemen known as implementation partners. So let's say if there is a researcher who wants to do an experiment or manufacture a new product in this one, they approach this middleman known as implementation partner. They actually develop this experiment or the experiment into a standard box sizes, you can say.
Mm-hmm.
This box actually needs to be taken to orbit and then actually brought back after the mission. So we are actually only facilitator for this box actually. So from our side, it's only the electrical and communication interface for this boxes, boxes. And so this is currently the way it is done in the International Space Station also. These kind of standard payload box modules are actually taken to orbit and then astronauts take it and put it in the rack of the station where and then they are connected with the electrical and communication and there the experiment happens. So this is actually what actually we are doing. So that is one of the reason where which enables us to focus on a large variety of problems because from our side it's just the payload module that has an electrical and communication interface. Whatever happens inside the payload
Got it.
module is directly the end researcher. So our direct customers are this implementation partner. We are actually speaking to a lot of them. Multiple MOUs are also being done, and they are also all interested in this area. And then this payload module
Lot of
actually is there.
excitement
So
out
I
there.
correct. So initial mission actually it is not. We don't have a payload completely payload volume. There will be a smaller volume, but right that is it is mainly decided to prove the re-entry and the on-orbit performance of it, and then that's it actually. The second mission actually is something that we will actually look at more longer duration experiment duration time where actually a lot more payloads could be. But the shape of the vehicle size, everything is the same. It's just that first one you don't
Got
actually
it.
put in lot of the payloads, and the vehicle is actually able to maintain the temperature, pressure, environmental conditions because it's a race vehicle and that is able to control all the environment. That all those things will be also validated in the first mission, and that actually provides the confidence to the customer saying that okay, your will not get spoiled while coming back or will not get damaged while coming back or in orbit
Yes,
phase. So this is
that
how
makes sense.
actually it
That
is.
makes super sense.
Yeah,
That makes a lot of sense. So y'all are mainly the logistic provider. You're the trucks
correct,
for stuff being carried sort of thing.
correct.
Y'all are
Yeah,
not
on
the
orbit phase
actual
and return.
implementation partner.
Correct. We are
So the
actually
only
so let's say
connection
if the
between you is electrical and what I'm guessing is you give
electrical
them electrical and
mechanical
communication.
communication interface. Correct. Yeah, these boxes or payload modules.
Okay.
Let's say if a research they want actually to be mounted in the payload volume, and then so basically it's like a cargo supply. We are only facilitating the
Yes.
on-orbit phase where we during the on-orbit microgravity duration or zero gravity duration, the vehicle is actually facilitating the experiments, and once the experiment is completed, it is able to facilitating means it could be just communication and providing the electrical power for the experiment, and after that it's
Yes.
able to come back
Yes.
and land. That is the only
Yeah.
interface that we
Retrieval. Retrieving the box and giving it to them again, I'm guessing.
correct. Yeah, once it is landing, we could actually the target we can land anywhere around the world because this is a controllable vehicle.
Yes.
Unlike a capsule which is not controlled, this vehicle is able
Mm-hmm.
to maneuver at you can target to land at any location around the world. So if there is a customer from see the American continent, you can actually target it to land there on a commercial runway, and then you will be able to. The design decisions are based on that it is able to land on a commercial runway. That is where I told about the making the vehicle as hazard free as possible, or completely
Makes
hazard
sense.
free. That's what the target is. So you can actually, because airports are high value assets on the ground, have high value assets on the ground. So your vehicle should also be able to provide that kind of confidence from a third party liability point of view, that okay, this vehicle is completely controllable and pose no safety hazard to the assets on the ground.
Makes sense. Makes sense. I'm guessing initially it'll be on all private, runways
Correct. The
before
first
to
mission will be
actually
on
get to
a,
the
yeah, first
public
mission will be on
runways.
a, it'll be on a private place, landing strip. That is also something that we have identified, and that is the mission studies are actually going on for that mission, like, and the different dispersions. So what happens if the entry point is slightly deviated from the initial nominal mission, and then how do you actually still able to reach that location? Yeah, that is where, because you are entering
Makes
at
sense.
around
Now,
25 kilometers per hour, and then you have to slow down it to zero, and you should also reach that location. You should not overshoot it or undershoot it. You should reach that location, but still you should not. You cannot also crash into that. You should also slow down. So it is a,
yes,
and you
yes,
get only one chance. So that is the controllability issue. And
absolutely.
then there are additional
And
constraints like you should cross the heating constraint or heating levels. You should not cross the G force or from a structural point of view, you
yeah, the
cannot go.
pressures and G-force.
Correct.
Yeah.
Yeah. So
And there's
all
also the
this
whole
actually
point of
makes a smaller
understanding weather.
corridor. Sorry.
Yeah. Understanding the weather conditions locally and only
Correct.
land when there's like absolute clear weather and you need to figure out how often can you
Correct.
get into
Correct.
that space in the long term. Those are all a lot of constraints. And then if not that particular location, do you have the ability or like the time to land in another location and then
Yes.
recommunicate back to your satellite for getting the right information
Correct.
and re-upgrading, updating the final drop position or landing
Correct.
position. These are all going to
Yeah.
be very critical pieces to keep
Correct.
liability low and also keep safety high and make sure that every mission becomes a success, right?
Correct.
At the end of the day, that's critical. Now, getting back into the microgravity stuff, like because those are your final, users, right?
Yeah.
You're mainly working for your users are going to be people who do microgravity research. So, what kind of products do you think? I've heard you say like lab grown diamonds, a lot of biotechnology, 3D bioprinting. You spoke about fiber optic semiconductors. So based on this, what I understand is this is a very wide range of companies that can do this. And also, this is very global rather than in India because there's very little awareness about this in India. Maybe there are like maybe two, three players in India that would be benefiting from this. Correct me if I'm wrong. Or there are two, three players in India that have funds and the idea of microgravity research and being able to actually partner with one of these integration partners and get this out. There's very little. So, is this a global opportunity? And if it is a global
Yes.
opportunity, are there untapped, what do you call, labs and what I call as researchers that you can hit because of this upgrade? Like, obviously, there's already a backlog for ISS, but given that you're doing this, is this going to unlock a new thing for a lot more researchers? If yes, how can they benefit? How can they plan for it after your first successful landing? Like, because for me, the moment you land, you're in business, right? You're just going to get
Yes.
orders. Now, how do you increase the awareness to these people? And what are the kinds of people
Yeah.
that you would be looking for here?
Yeah. So it is a global market, definitely. That is the more mature. We are also sensitizing this benefits of microgravity in the Indian ecosystem also with the Indian players. Many of these some are pharma companies who actually wanted to look into this area. And in the bio area, so low hanging fruits in this are semiconductors and pharmaceuticals are drug research are like the earlier hanging fruits in this microgravity, which comes under the area of low volume, high value products. So that can also afford to
Yes.
actually go through the current launch prices and then do the experiment in zero gravity and then come back. And this is, yeah, it is more mature in the West. And a lot of activities are actually happening in India also, with the ISRO announcing a microgravity challenge for an announcement of opportunity for research, microgravity research to be carried out from India. This is also a new challenge that came, an announcement of opportunity that came. So we are also part of that. And in this, uh, we would want to also sensitize this benefit actually. So products could be anywhere from crystal. So it all depends on the process. So there are three main changes happens when you turn off gravity. One is absence of sedimentation, absence of buoyancy, absence of natural convection. Sedimentation means things don't settle down in space and mind. Absence of sedimentation means
Yes.
things don't settle down. Absence of
Hmm.
buoyancy means things don't, the bubbles doesn't rise up in a zero gravity
Hmm.
environment. And the natural convection is
Yeah.
when the absence of natural convection is when the hot water wants to go to the top and the uh, cold dense water wants to
Settle
go to the
bottom.
bottom. It sets up a current. Actually. This convection current is also not present in zero gravity. So
Makes
whatever
sense.
process that actually gets affected because of these three can actually be made better in when you turn off these sections. That is a whole overall basic of this. And there are a lot more products. It could be crystallization, it could be 3D bioprinting, it could be fiber drawing. All these are actually or semiconductor reprocessing. All these are actually based on these three concepts. And in addition to that, there is vacuum also. So
Yes.
in India, we are looking at this many IITs. In fact, IIT Madras has a center of excellence known as extraterrestrial manufacturing group. We are also actually entering into an agreement or understanding with them, with us actually sensitizing this or creating awareness that lot of benefits are there. A lot more products can be made in surrogate. Just that it has to make economic sense with the current launch price. So you can make even coffee in space, which is actually proven that
Yes.
it tastes better. And lot more cosmetical formulations can be made. I think colloidal formulations can be made in zero gravity, which are more stable and it has. So all these are based on research carried out in the International Space Station and earlier space station. So this is the challenge is actually in Indian market a lot more awareness need to be generated. That is something that we are also
Yeah.
doing and talking to all these multiple players, different players on this one. And we are also talking with the government bodies on this one. Actually. In fact, that is what actually the
Makes
ISRO
sense.
also had, uh, on, yeah, brought up with the
Makes
IMEX
sense. Makes
challenge.
sense. Makes sense. So I know you spoke about the actual products that can be built. Now, I would also want to ask, obviously, one side is research, the other side is manufacturing that you were talking in the end. So these are going to be bloody expensive. I understand. So what kind of numbers are we looking at for a single payload or for a single launch? Obviously, your launch costs are expensive. I'm sure you need to piggyback off third parties, like either with the ISRO itself or like any international player if that's what the requirement is at the end of the day. Uh, can this be launched with any launch vehicle, or is this any specific kind of launch vehicle you all are looking for that this can be launched with? Uh, that is the first question I have. And the second question is, what kind of numbers for this experiment? Like, is it going to be, hundreds of thousands of dollars? Am I looking at millions of dollars? Like tens of millions? I just want to get a estimate. Like, because again, this is a 2 month window where you have your very high risk system in space and that deorbits with extreme high risks for you. Just want to understand what kind of numbers are we looking at here.
Yeah. Yeah. So the launch from the launch part, this vehicle is launch vehicle agnostic. So as I mentioned, it's only depending on the adapter. You can actually choose any launch
Mm-hmm.
vehicle. It can go in a dedicated mission on a small launch vehicle because of the form factor size is actually smaller. Can fit inside small launch vehicles. Or it could also go as a ride share mode in a larger rocket, like the way Falcon 9
Yes.
share, you can share your ride to a larger. So both the possibilities exist where you can actually share
Mm-hmm.
the ride or go on a dedicated mission depending on. So but ride share missions you would actually have to go through a waiting because it happens every 3 to 4 months and then you have to look at that. Or if the customer wants it to launch on demand, this launch dedicated launch is also possible on a smaller launch vehicle. And the products,
Mm-hmm.
as I mentioned, early hanging fruits are mostly products which are low volume and high value. So, in fact, the payload mass that we are looking at is a 100 kg payload mass and 1 meter cube of volume is the payload volume that we have in the spacecraft. That actually enables. So, if you look at pharmaceutical crystals, they, for example, the entire COVID vaccine of Pfizer is only a few gallon or maybe a few gallons. So you don't actually need to have that many. So this is not the actual that is actually diluted and given. This is actually the active pharmaceutical ingredient in that. So low
Yes, yes.
volume actually justifies you can actually still do this and then come back. So crystallization also actually can actually be made. A semiconductor ingot can be made in there and then brought back, which can actually lead to a lot more semiconductor devices can be made from one big ingot that is made in
Yeah,
this
bigger wafer. Yeah.
yeah. So because these are low volume and still can you can actually have enough value to afford the launch price. So launch price is also coming down with the multiple new players and new innovations happening in that with reusability and booster reusability and even second stage reusability is also looked at. So launch price is coming down. More and more players are entering. That means you have more access to launch vehicles, and then newer commercialization of these products are being understood. So that needs to be known, or that can be scaled up. That is also happening. So this all led to a phase. And then coming to the cost, you say currently it's around 80 to $100,000 per kg for the up and down phase. We would want to actually
Okay.
bring it down to half of this. Yeah. So launch price is around
Got it.
$10,000 per kg. That is only going up part, but the up and down part is currently around 100,000, 80 to 100,000. So that's
Mm-hmm.
something that we would want to fit with this unmanned. And partly
Got
it's
it.
because of the human in the loop that is coming actually. So because you would want to actually over-engineer your system or your vehicle so that you don't you can afford multiple failures. Or let's say if there is some failure in one of the
Yes.
system, a redundant system actually takes over and still looks. And that may not be the case actually when you are an unmanned vehicle. You can actually afford
Yes.
to have lower constraint. So that is where if you, some
Mm-hmm.
human rated vehicles are actually more expensive than a unmanned vehicle. That's the same concept actually, a lot lesser system in terms of architecture.
Got it.
Yeah, this is
Now
the
my
what
question,
is.
yeah, now my question is, are there experiments? I know you want to get this thing back. Obviously, I know you want to get the whole payload back. But initially, there's higher risk. Obviously, people are going to be like, maybe, it's a new player. I'm not sure. I know they did a, landing and everything, but I want to make sure things work. Are there payloads that would only need the data rather than actually bringing the payload back? They care about the research that happened, the numbers and the details that they get, but they don't care much about what comes back in the payload. Are there researchers like this? Because again, obviously, I'm just thinking from your perspective to figure out low risk initial launches, right? Finding payloads that will be low risk. They get the Gs, they get the data that they want, but then they're like, okay, payload is it went away, but I am not losing a lot of money by doing this, and it at least gives you a confidence for doing one or two or three of these launches without extreme risk for your customers. Is there anything like that for you all?
Correct. I think the implementation partner also are also looking in the same, thinking in the same manner where initially they would be more caring about the data and if at all they get the product back, it is actually a bonus for them. And in fact, they are
Mm-hmm.
also showing interest in the first mission itself, as I mentioned,
Mm-hmm.
that they would want to actually look at just get the data back and then if the vehicle survives and lands back, the payload can be retrieved. That is actually a bonus. So even in the first mission, there is actually sufficient interest that we are getting from these implementation partners to fly their payloads. It could be simple experiments, just like heating or crystallization experiments that could be performed. Some biological experiments are also planned, and this would they are initially looking at the data of that. Yeah,
That makes a lot of sense. That makes a lot of sense. Now,
correct.
I heard about every piece of this, right? But now let's get back to your life. We have spoken about your company. Now, this is about founder life. How has founder life affected you? What has been your life? Are you like, how has it affected your personal life? How has it affected like, your day-to-day life? PhD student, obviously, you were already in that mode, if I'm not wrong.
Yeah, yeah. That
Working
is
on
what I was
PhD, you were
beginning to
more or
say.
less in a
I don't
founder
feel a
mode.
change.
So I'm
Because even
guessing
when
you
you are
were
a
already
PhD,
in
you just
founder
work
mode.
every day, 7 days a week. Even when you are a PhD, you just work 7 days a week, and it's the same thing now. So I don't feel a change.
Yeah, yeah, I understand. Now, what keeps you going? Like as a founder, there are some days you're like, man, this is tough. I am. this is like, I don't want to do this anymore. What keeps you going in those situations? How do you decompress?
Uh, yeah, it takes small breaks in between to actually just come back with a refreshed mind to look at it. I do take breaks in between, but it is a decision that had taken, and I knew that it was a difficult path, but I don't feel actually there is no pulling back kind of thing that I don't want to do this kind of a thought never came because every day is actually
Mhm.
becoming more exciting as the earlier day because of things that is
You're getting
happening.
closing. Yes,
Yeah, yeah, we are getting there actually.
you're
So
on
I
this
see it
side.
in three different,
Yeah, yeah.
yeah, three different layers actually. So the daily things are actually at the lower level, and the mid level is there are a lot of processes happening. And on the high level, there is clear progress that actually that keeps you motivated. So if you just zoom out and see what is happening overall, this thing there having been, there's a clear motivation, and that actually keeps you going.
That's great. Uh, throughout the ecosystem, I know you've had a lot of mentors who helped you, a lot of people that you spoke to. Like, are there any specific people? I mean, obviously, different people have different, kinds of people that they, look up to and, feel as their mentors. Are there like few people that you think are very critical to you throughout your journey, and, how you would recommend people other than like to the like other founders to find these mentors, get feedback? What was this thing that you tell the new founders?
Yeah, yeah. So this access to advisors and mentors was actually enabled because of being associated with IIT Madras. Many of the technical advisors are actually from former ISRO, and they are also professors of
Mm-hmm.
practice in IIT Madras. I got access to them because of the same reason,
Mm-hmm.
being in the campus. That was actually a blessing at the Nirman pre-incubator.
Mm-hmm.
And
Mm-hmm.
this is something that I also speak to multiple founders. If you can get associated with the institution which has actually had a good, which actually have a good has a good startup ecosystem, it would be better for you to get a visible platform where you can actually move, take it forward from there. So IITs or even other institutes are also having a lot more incubation or facility there. So this is, and depending, the mentors will be different for different people, and both technical and uh, non-technical
Non-technical.
mentoring is also supported, facilitated by uh, uh, the incubation and the pre-incubator. And even actually, there is strong alumni support to IIT Madras. So in fact, I was actually financially supported during the early days because they would want to
Mm-hmm.
encourage PhD students getting into entrepreneurship. So I was actually, and there was an
Mm-hmm.
alumni fund for that. So for the same reason to support.
Mm.
This is actually is there in some of the institute with their alumni funding this. So that also helped me in this one actually, early stage.
I mean, I hear you. I hear you. You're on the top, like, IIT Madras, literally the best incubator slash thing in India right now. There are so many deep tech and tech companies and like manufacturing companies coming out of there. Obviously, there is like you're at the cream of the crop sort of situation. Now, how do you bring this down? Obviously, you can't really put yourself in other person's shoes, but how do you get the other breed of founders? Obviously, a lot of people are still in B2C, D2C, making sales, like doing sales sort of stuff. That side,
Hmm.
like we have a lot of talent, we have a lot of, engineering talent, we have a lot of technical talent, but they end up going more towards these problems that are direct to consumer rather than deeper technical problems. So how do you tell them to approach these problems and get their initial thing validated? What are the easiest paths? Are there any paths in, in the overall ecosystem that you have looked at, not just at IIT Madras, but grants and things like that, so that people can get started quickly without taking extreme risk upfront?
Yeah. So deep tech is a harder problem. There's no doubt about it. Uh, and you will need a lot more patience also, and you will need to. It is a decision that you will have to take yourself that you are fit for this journey. And as I said, I think with my understanding, getting access associated with an institute, a partner institute, and even IIT also allows application for friends or other
Yes.
incubators are also a possible way to actually get a platform where you can a lot of things will be sorted out. So for the common can say the common services, for example, the incubation cell provides a help support in many of these common services, which are actually common to a lot more. So you don't have to figure it out yourself a lot more, and then being in a place where other founders are there also keeps you motivated and also makes you to learn from them. That is the way I feel that
Absolutely.
any founder who's willing to get into this can. And particularly regarding deep tech, it is also to have a conviction that you will be able to do that. That conviction should be there,
Yes,
and
indeed.
also
Yes.
patient, because it's a little bit more harder journey, and because you will not be achieving a revenue, and you can also still look at strategies to actually generate some of the early revenue. In fact, that is something that we are also looking at, some alternate revenue streams with some of the subsystems. So these way you can actually still target your journey to reach your end product, but it takes a lot more time than the non-technical startup kind of thing. Yeah. So founders look.
That
What I would like to say to them is yes, if possible, get associated. Otherwise, still there are a lot more avenues or a lot more conferences or events where you can actually still be more visible. That was a way you can actually still get going.
makes sense. Makes sense. That's like solid advice. Actually, surrounding yourself with founders is a very important thing. Like, you don't want to be around people who are not sharing a similar goal or at least looking to build stuff. If you're not
Yes,
around builders, you might get demotivated. I mean, not everyone
correct.
is naturally motivated, right? So it's pretty hard. Um, I guess I've asked most of the questions, right? Arvind, like pretty much I've covered end to end. Is there anything else you want to share during this conversation?
No, I think I pretty much covered everything, and looking at yeah, looking forward to more announcements this year where we would actually
Oh yeah,
more milestones would
we
be
look forward to it.
I think very soon. Yeah, we will soon. We are very near to getting it. So just that we have not announced it. So something that's coming
Yeah,
very
no, I'm
soon.
not gonna. No, don't need to make an announcement upfront. We'll just wait for it on your press releases
Wait
or
for
any
it.
of
Actually,
your
yeah,
LinkedIn posts.
yeah,
Yeah.
it's coming.
So no, it was
It's
great
very
talking to
soon. We're
you.
very near there, and
Yeah.
it's coming. Yeah.
It was great talking to you, learning from you about your journey, about your company's journey, and how space tech is evolving in India, and how many opportunities are out there, and how much IIT Madras has helped you, or the space, the government changes to the regulations which helped you become a possibility, right? Like whatever you're doing is possible right today because of all the support and well wishes from everyone. So I'll add on to that as another well wisher, Arvind, and thank you so much for this. Right? Thank you. I'm gonna
Thank you.
stop recording.
Thank, yeah, thank you, Prashant.